want to welcome you to my lecture today. Initially, I proposed a topic of spleen regression for today, but I changed my mind. You know why? Because I realized I needed to walk it through one more time on how to do interpretation of regression parameters when interaction is involved. When interaction is involved, it could be interaction between two continuous variables. It could be interaction between two categorical variables. It could be interaction between a categorical variable and the quantitative variable. So, and that is why I am actually, coming again, because I realize students, based on my experience, I think they normally have issue with how to, interpret this. So in the outline, when in a model, when you have a continuous, when you have a predator or two predator, one is continuous, one is categorical, how do we interpret? In a model, when you have interaction, if interaction is between two categorical variables, how do you interpret? If it is between a categorical and a continuous variable, how do we interpret? And that's the reason why I really want to focus on this again, so that you'll be able to understand. Now, because of that, I will walk you through what we've done before. If you take a look at this example, initially, we basically want to look at the effect of age on, on the amount spent traveling. Even though we know that people travel for different reasons. In the data, people travel for adventure and they travel for cultural. Now, as part of preliminary investigation that we do by trying to generate a scatter plot, we realize this guy here, when you take a look at that, it's trying to tell you two slopes exist. This we have in different direction. The black one is A, those who travel for adventure, and the red one is C, those who travel for cultural. And let's say I want to use this graph now to make a decision. If I want to make inference, if I really want to know somebody of age 30, okay, okay, how much does that person really spend? If I use the red line, the result that I'm actually going to have will be different from when I use the black line. When I use the red line, okay, I will underestimate. You know that? I'm going to underestimate, because from 30, maybe it's going to give me around like 600. But when I use the black line, what am I going to have? I'm actually going to overestimate. And don't forget, that line in the middle. That line in the middle is the point of interception between, the two. So which means the first model that I actually want to use, looking at the effect of age alone, okay, it's not going to do a great job. There's going to be issue. We're going to mislead. Now, the fitted model based on the age is what you are seeing. This fitted model is assuming that the intercept is 957.91. Is that true, as suggested by the graph? That is not true. The intercept of these lines are not the same. Look at the intercept of the red one. Look at the intercept of the black one. Don't forget, intercept is where the straight line touches the vertical axis. What the picture is showing is not showing that they have the same intercept, but that model is actually suggesting the same intercept and the same slope. And that is not, that's not true. And which means based on this model now, you can answer a question about how customers in segment A relate, how customers, how age relates, to a month for customers in segment A and for customers in segment C. There's no way you'll be able to handle that, because this, that very model that I'm showing you now, is only telling us they're going to relate the same way, but they are not going to relate the same way, and therefore it's not a good model. If I want to interpret age here, I'm assuming that age here does not interact, or there's no any other variable that will influence that relationship. That's exactly what we mean here. But when we now decide to introduce the effect of the segment, age is a continuous predictor, okay, and segment is a categorical predictor. Now, if you take a look at what we have now, when we run that, we got a new model, right? If you take a look at this model, the new model that we have, this new model will give us two lines. I want you to see those two green lines. Okay, I'm going to tell you something about the two lines. Even though we record an improvement, what is it telling us? When segment C equal to 0, what happened? When segment C, when segment C equal to 0, that is segment A. You know that, right? Because what is reported is segment C. It means arrow has automatically coded segment A as 0, which means it's reference that. So when you plug in 0 for segment A, okay, you will have the intercept will be 963.43, okay, and the slope for H will be 1.09. But what if you plug in 1 for segment C? When you plug in 1 for segment C, what will happen? The intercept will change. But does the slope change? No. The slope is still going to remain minus 1.09. But what are we looking for? We want a situation where the intercept and the slope will change, as suggested by the shape that you are seeing. So which means this current effort, only help us to make the intercept to change, but not the slope. It's still assuming the same slope for the two, even though there's an improvement, but we have not gotten to our destination. So if I want to interpret now, if I want to interpret for H, okay, so in interpreting that negative 1.0939, we are actually putting into, we are adjusting the effect of segments, adjusting for effect of segment, in interpreting that guy. Okay, whatever our situation where we consider the interaction, we're considering interaction effect with the main effect. We have main effect of H. Okay, don't forget what is missing here. The main effect of segment is missing. You know what the main effect of segment did the other time? When we introduce the main effect of segment, the intercept changed, but the slope did not change. But now we are introducing interaction, but we did not consider the main effect of segment. And we basically want to see what happened. Now, what happened in the process, right? This is still going to lead us. This is leading us to what the model we have now. What is missing there? 2.24 is basically going to be the interaction H segment, right? That is what you're going to write here. Now, when I plug in, so what I'm trying to say, give me 1 second. In what is, let me see if I finally put that. Oh, let me see. Oh, I didn't put that. Now, but what is missing is just the interaction, H segment C. Now, when you have H segment C, when you plug in, when segment C equal to 0, okay, you're going to have intercept 962.33. The slope is going to be negative 2.34. When that is equal to 1, of course, the slope is basically going to change. When the slope change, intercept will not change. Do you see what I just did right now? I'm going to show you it on the board. I'm going to write that on the board. Give me 1 second. Now, what actually happened is this. Let me just. Okay. Now, if you want to go by, what we have here, amount. Let me just say, let me shorten that amount. 962.33, okay, minus 2.34H, okay, plus 2.24H segment C. When segment C equal to 0, what happened? We're going to have this as intercept and this as slope. But what if when segment C equal to 1? When segment C equal to 1, it's going to be 962.33.234H plus 2.24H1. Automatically, the slope is going to change because there's a H here, but the intercept remains the same. Now, the second effort, what happened? Intercept changes, slope does not change. Then this effort, slope changes, intercept remain the same. Have we gotten to our destination? No, because what's our intention? We want both slope and intercept to change. Because of that, we're going to go. So that is what you are actually seeing now. It's taking shape. Now, take a look at this guy now. We have the main effect of segment C as well as the interaction. Don't forget, when we consider them separately, when we introduce, even though the primary variable of interest was basically age, okay, where we incorporate a covariate, a segment C, the intercept change, when we incorporate the interaction, the slope change, intercept does not change. But what if we now incorporate the two? Incorporating the two will make both slope and intercept to change. And which is what we're doing here. And if you take a look at what I'm displaying now, right? If you look at the model, if you look at the feature model, when you plug in, when C equal to 0, what happened? When C equal to 0, the intercept is going to be, the intercept is going to be 181.4.54. What if C equal to 1? When segment C equal to 1, the intercept will basically change and the slope will change as well. They want to try that? Let plug in. When C equal to 1, when segment C equal to 1, what do you have? The intercept is going to be 1814.54 minus 1821.23, which means intercept change, right? What about the slope? Slope, we're also going to change. The slope is going to go from negative, we're going to have negative 20.32 plus 40.45, which means this intervention allow both slope and intercept to change. Does that make sense? Okay, and that's exactly what we have. And of course, now that was why I made this conclusion. Okay, go ahead. Okay. Yeah. You mean for where when is there? Yes. Give me 1 second. Uh, yeah. This line is being actually great, right? So suggesting 1,000. That's what's going on. You know, this is just for so I understand what you mean. Okay, so take a look at that. Okay, go ahead. That's a very good question. You know what you're gonna do? You go anywhere you need to produce a new model by plugging in 0 for segment C because it's focusing on segment A. So when you push 0 on segment C, so what you are trying to tell me now is this, you know, uh, for segment for segment A now, okay, for segment A, amount cap, you plug in 0 to anywhere you see segment C, right? So then you're basically going to have 1814.54, okay, minus 20.328. This is your model for segment A. How do you arrive at that? You plug in 0 for segment C. Anywhere you see segment C, here, okay, segment C equal to 0. When segment C equal to 0, you are referring to segment A. Now, how will you now get for segment C now? Then it means plug in segment C to be equal to 1. When you plug in segment C to be equal to 1, okay, you have 20.32H and 0.32H. Let me, so that this can capture that in case you guys want to watch the video again. Now, what I'm trying to say in essence is this equal 181.454 minus 20.32 H, okay, minus 1821.33 33 segment, I mean 1, okay, plus 40.45H1. What is going to happen? The new intercept is going to be, you have to do this minus this. The new slope, combining that. What has happened now? What has happened now? The slope as intercepts, they are not the same for both segment A and for segment C. Does that make sense? That's exactly what. So they are asking you to produce a model, or anytime you see that question like that, you're plugging in into for segment C. That's a good question. Now, this is what happened. If you want to talk about for segment C now, the slope you're going to be using is going to be not only, you're going to combine this and this. What has happened to the slope? There's a change. What was the change in the slope? This guy. Initially, the slope was this guy. That was the change. And do you know what will help your interpretation? This guy will help your interpretation. Do you see that? That will help your interpretation. When you had the main effect of segments, what happened? That allowed intercept to change. Which intercept is changing? Intercept between two groups. Which slope is changing? Slope between two groups. Go ahead. Okay. That's it. You are asking me a very interesting question, which is one of the reasons why I decided to repeat this today. Do you know that under this arrangement, these are more or less like averages, these estimates? You know why? The first one, the intercept that you actually see, that would be that is what? When you're talking about segment A and the age is 0. Does that make sense? That is the amount, the average amount spent travel. But if you look at the effect of age now, right? When age is involved, right? That effect is negative, which means what will happen to the initial amount is going to go down by what? By 20. You see that, right? Now, when you now look at segment C now, the segment C is now going to tell you when I move from one segment to the other. Does that make sense? Because when you want to interpret the predator, you're going to say for every unit increase in S, what is the effect on the response? But right now, the segment is categorical. It has two levels. When we want to talk about a unit increase, is a movement from a class to another class. What does that ask on the, on the amount? That's that guy there. Does that make sense? Okay. And the interaction now is just going to tell you that when you are looking at the relationship between age and the amount that you spend, that now depends on the class you belong. Which class? Whether you are traveling for expenditure, for cultural or for adventure. That is what that interaction is talking about. The interaction is always saying that, oh, if I want to look at the effects of this predator on the response, that relationship, okay, that predator depends on another predator. This time around, that now depends on a class, which means age as a factor is not consistent. You know why it's not consistent? The performance of age as a factor on the amount spent is not consistent because it differs depending on the level, on the segment that is provided. It is significant. Anyway, now I'll give you more. I will give you more. Now, take a look at the first one. What would be your answer when you use the first model? It's assuming same slope, same intercept. When we introduce segment, what happened? Different intercept, the same slope. When you introduce age segment without the other one, is giving us probably different slope, but the same intercept. But when the last one is basically going to be different. Does that make sense? Okay. Now, and of course, you remember the other time when you are interpreting now. Okay, now take a look at this. This is what we are talking about. Segment A for the first one. And the second one is still going to be segment A. You know why? Because the age that you see here, that is the primary variable of interest, we basically, that minus 20.3175, we got it the other time when we actually plug in 0 for segment C. And when you plug in 0 for segment C, what are you talking about? Segment A, right? Okay, I quickly want to go to something else. I wanted to take a look at this guy now. I'm working on the effect of race and sex on a particular response. How many categorical predator do I have? I got 2, right? And each of these categorical predator has two levels. Of course, if you take a look at for sex, male and female, right? Arrow reported one level, I told you. For race, two, we consider two. Arrow reported race black. Now, the race black means that Arrow is coding black as 1, maybe the other race as 0. But let me tell you something. That does not mean the one that is coded 1 has a numerical advantage. Oh, that's not what we're saying. The other one that was coded 0 that we're not seeing is being used as a point of reference. Now, how do we interpret something like this? There's no continuous predator. The two of them are both categorical. How am I going to? Now, the first intercept that you see, that will be the mean of white males. Why do I say mean of white males? Because the male was coded 0. Then the other race was also coded 0. Any question about that? About why the intercept is that? Any question? Why we say white males? Any question? Okay. Now, what about it? Now, if you now want to talk about the sex female now, okay. Now, the sex female is different between the mean of females and the mean of males. The difference between, that was what I said. Then for the race black will be the difference between the mean of black and the mean of white. Which means what you see in the estimate is representing like a difference in means. The intercept is the mean when you are focusing on the reference maybe group. But don't forget, there are going to be two reference groups here. The first reference group is male. The second reference group is white. And if I want to consider the intercept now, it means when the predator equal to 0. Any question on this? You know, I'm bringing this so that you'll be able to know how to interpret. Now, I want to go to the next. Oh, my God. This is a complicated one. You know why this is a complicated one? We have one quantitative predator. We have two categorical predator, and they also have interaction. Look at that. How do we now interpret? You know, sex equal to 1 if male, like in this example, we are coding male as 1. We are going to code female. It means female is going to be coded as 0. And the race, in this example now, we're coding race. You know, race equal to 1 for whites, race equal to 0 for others. Does that make sense? Okay. Now, we're looking at the effect of education, the sex, race, as well as the interaction of race and race. Oh my God, there's a lot in this model. How do we interpret this? Let's start with the beta 4. What is a beta 4? That is the interaction, right? When you want to interpret that interaction, you need to mention what arrow coded as 1. What does arrow code as 1? Male and white. And that was why I said if an individual is male and white, his wage will increase by beta 4. You know, I'm using increase here, provided the sign of beta is positive. If it is negative, I'm actually going to say decrease. Now, do you now understand how to interpret that interaction now? That's what I mean. Now, what about for beta 2? You know, what does beta 2 represent? Beta 2, the contribution of sex, but don't also forget there's another sex in the interaction, right? Now, the beta 2 I say will be if an individual is a male and his wage will increase by beta 2 plus beta 4 race. Why? Because if it's a male, the sex is going to be equal to 1. Isn't it? Look at what I said from the beginning. Sex equal to 1 for male. Plug in 1 where you see sex. What are you going to have? It's going to be beta 2 plus beta 4 race. Because you have plugged in 1 in place of sex. Look at that. That is the way that's going to be done. Now, what about beta 3? Of course, the beta 3 is the one that's associated with race. Okay. Now, it would be if an individual is white, don't forget, I'm focusing on the one that's coded 1. Okay, because when it is white is when I'm going to plug in 1. Look at the beginning. I said if race equal to 1 for white. Okay, when I do that, it's going to be beta 3 plus beta 4. Any question on this? Any question? Go ahead. That's a good question. I'm gonna walk you through. You're gonna see what I'm gonna walk you through that one today too. When I have more than 2 categories, what happened? You will see that now. That's a good question. Okay. Let me see. Which one? It's a beta 4. No. We're talking about if an individual is male and white, right? Male and white, okay, his wage will increase by beta 4. You know why? Because beta 4 is a contribution of that interaction. Does that make sense? Okay. Yeah. Yeah, which is which is another thing that I'm talking. Maybe this is what you're talking about. The last one here, right? Yeah, that's why which means you guys are following what I'm. Good job. That was why I add that. Good job. Okay, if a person is a male and white, the wage is increased by because you're plugging in one for male, one for exactly. Okay. Now, somebody now asks this. We have a categorical variable, but it has 4 levels. Look at that, 4 levels. When it has 4 levels, we're only going to have how many in the module? 3. That will be 4 minus 1. 1 will be reference, right? Okay. Now we're considering lower, region in the United States, Midwest, West, and South, the Northeast. Okay. And we're looking at the effects on the salary, whether does this region have the same salary? Does that make sense? We're looking at the effect of region on salary. This is a fitted model. How do we explain the model? 96.6, what does it represent? Then we are focusing on the one you reference. It means the one that is showing in the model, what is the value? You're going to put 0 on them, isn't it? Does that make sense? So 96.6 now is a situation where the region that you see equal to 0. The region in your model equal to 0. That's what you see. That's why I said location Midwest equal location Northeast equal location West equal to 0, which means what am I focusing on? I'm focusing on the South. Why is it South? Because South is reference. And when it is reference, the focus is on South. Does that make sense? I'm going to say it again. You got 4 region, right? It is not going to be all the 4 region that will be reported. One needs to be referenced. Now, if I ask you what does it mean, which means 96.6 is the average salary for people in the South region. But how do I get the salary of people in the in the Midwest? When you take a look at the Midwest, the coefficient was negative 2.94. The negative 2.94 was a difference. Difference between what? The difference between the South that you reference and that region. If I really want to know the mean for that region, what am I going to do? I will do the intercept. Then I will consider the negative that 2.94. 96.6 minus 2.94 will give us the average salary for that particular region. Any question? The same thing applicable to others. What am I finding here? The average salary of each region. which means what you see in the intercept, they are not the average salary. The only one that is the average salary is the intercept. The other one that you see are the difference between them. Okay, look at that. That is the interpretation. I'm going to show you another one. Oh my God. Here I got two categorical variable. One has 2 levels. The other one has 4 levels. You know, the 2 level is public, private, public and private, right? Then and region. You know, we're still talking about salary, but in here we only consider effect of region, effect of location. But in this one, we are now considering not only effect of location, we are also incorporating whether you work for public or you work for private. So now you see public, right? It means arrow coded public as 1, private as 0. Any question? Okay, what is the meaning of 99.556 now that you are saying? Somebody who work in private and also not from this region that is being displayed is from the which region? South. Good job. Send me a message for extra credits. Now you can now see the other estimate. There are differences, not just okay. That's what I mean. Now, if you want to know more, that's exactly what I'm working out here. Oh my God, I'm working them out here. Look at that. The first one is talking about private, and when I'm not interested in the region that is displayed, I'm interested in the region that was referenced, which is the South, and so on like that. Is there anyone who have any issue with that? What I'm displaying on the board is just the average salary for each of that, which means I'm actually using the estimate, the combination of the estimate and the intercept of the estimate of the regression parameter. Look at that. The last one I want to walk you through. We're looking at the effects of gender and whether they attend college degree or not on the harness. But the harness is log, it's being logged. The reason why it's being logged, maybe because of the fact that when you draw a scatter plot, the relationship between the response and the predator is not a straight line. And maybe only way to attain linearity is to log, to find the logarithm of the response. Okay, now, if you look at equation 1, equation 1 is without interaction. Equation 2 is with interaction because age, okay, gender, the contribution of gender to earnings may depend on whether they attend college degree or not, or the contribution of college degree to earnings may depend on the gender, and that is why you are having interaction. Does that make sense? Okay, now how do we interpret beta 1? How do we interpret beta 2? And how do we interpret beta 3? By beta 1, beta 2, beta 3, we're not talking about average. Don't forget. If I want to talk about average at all, beta 1, the intercept. Beta naught is the average. But beta 1, beta 2, beta 3, they are not average. They are like difference. If you want to talk about the average, then you're going to be considering all this. Okay, I want you to take note of that. Now let's take a look at it. I said beta 1 measures the average difference in the log and between individual with and without college degree. Okay, the beta 1 is the coefficient for college degree. I wanted to take a look at that. The beta 2 is the coefficient for the gender. And that was why I said the gender differential in harness, in the log of the harness. Then what about beta 3? The beta 3, I want to talk about the interaction now, the one that's going to tell you this particular predator depend on another predator. Okay, so the beta 3 measures the difference in the effect of having a college degree for women versus men. Effect of having a college degree for women versus men. Okay, don't forget, effect of having a college degree for women versus men. That is where we normally have the both the intercept the slope changing. Does that make sense? Any question? I think the reason why, like I said, the reason why I'm bringing this is because I know interpretation is very crucial, and some students don't get it right, and that's why I'm bringing it. Okay, I think next week is a midterm, right? Or the week after. Okay, if the week after is midterm, the topic for today that I call split regression will be done on Monday, and Wednesday will be where I'm actually going to walk you through midterm 1 practice review, where I'm going to tell you a lot of expectation. And let me tell you, make sure you take that midterm 1 preview that I'm going to do on Wednesday seriously, because for those students, for my past students, I always follow the trend of the way the midterm 1 preview is. Does that make sense? So on that day, I'm going to tell you what you need, whether you're going to come with 2 sheet, Okay, go ahead. Exactly. Oh, you mean before the preview? How we ensure that all assignment solution in? That's a good question. Go ahead. Yeah, yeah, you can, yeah, if you do that. But if that is not working, I'm flexible. My TA, I also allow people to write, but provided you write legibly, clearly. And when you write, you want to scan, make sure you save it in PDF. Does that make sense? So whichever way, we only want to see that what you write is very, very visible to grade. Okay, it's another weekend. Make sure you stay safe, enjoy your weekend. Bye for now, everyone. Oh, we're done on time, right?